And see what we go into. We're introducing you guys to functions. So you're going to be able to identify what a function is from the definition of it, and then use function notation to evaluate the function. So those are the two things we're looking to do. And then we do want a couple of things in. Once we understand what function notation is, connect it to a couple of the things from chapter 4 that we've already studied. So if we take a look, I'm going to start describing some terms that we use in functions, and we have to define those terms before we can really start talking about what a function is. So the domain of a function is the set of x. Sorry guys. It's just the x variable. I got a long, a big space there. Is the x variable or the input values. I'm going to have to write a little bit of an angle. Do you guys have more space there on yours than I do? Okay. All right. So you guys have enough space to write this in there. So the domain is your input. It's your x values. It's what we plug into our function. The range then is our y variable or the outputs. And so we use all three of those words. We'll start talking about the domain. We'll start using inputs and outputs to define those. But what we have to realize is that these are just sets of ordered pairs. So they have an x and a y variable each time we talk about the function. If a relation is a function, it has exactly one output for each input. And so what that means is each x has exactly one y. All right. So I'm never going to see the same x value twice in my function. I'm never going to see that because the x value only has to be listed once for its one y value. A relation is just a random set of ordered pairs. Okay? So we're going to start looking at these relations, these sets of ordered pairs, these graphs of ordered pairs, and see, do they make a function? Do they fit that definition that there's exactly one output for each input? And then function notation is listed as f parenthesis x. We call that f of x. So read that, f of x. Or f at x. All right? So it just means you're evaluating the function for x. And I'm not sure how much room you guys have for all of that. Right? So when you see f of 2, they're saying, hey, your input is 2, plug it into the function. When you see f of negative 4, f parentheses negative 4, they're telling you your input is negative 4, plug it in and evaluate the function. Evaluating means we're going to work it out following our order of operations. Can I go to the next screen? Okay. Whoa, I asked. Yes. A set of ordered pairs. Yep, they're just ordered pairs. So it's just any combination of x's and y's. So for a relation, the x's could repeat. We could have 1, 4, 1, 7. So an x value could have multiple outputs, different outputs. But once we say we have a function, each x has exactly one y value that it outputs. All right, so here's some examples of relations. These are just set of ordered pairs. These are what we call mappings, ladies and gentlemen. Label those as mappings. I'm not sure if we have you do any mappings, but you will have to read those. So one of the first things we want you to be able to do from a mapping is to name the domain and range. Well, the nice thing about a mapping, ladies and gentlemen, is they give you the domain and range right there. If you remember that domain is input, your domain is the set -3, 1, 4. We use set notation, so it's kind of like the curly brackets, so it's not just parentheses. They kind of parentheses, point out with a V, and then curl back in. And they're written in order. I usually go least to greatest. You can write them in the order of greatest to least, but you need to write them in order. And then if we look at the output, the same thing. We're going to write it as a set, and we're going to write it in order from least to greatest. Now here's the problem, guys. I do believe that this one covered up the -3, so this is -3, -2, 1, and 4. Because when you make your mapping, those should be written in order from least to greatest, but I think our order arrow covered that up there. So for B, who thinks they could name the domain for that one? What would the domain be for that one? Maggie?
63.1.
Good job. And then the output would just be, or the domain, the range would just be the outputs. The -3, 1, and 2. That one doesn't look like it's covered up as much, so it must be missing the -3 there, guys. So guys, go back up here, add the -3 in there. It should have a negative in there. I don't know if there's something when we try to draw the arrows in, if we're covering things up there a little bit, so we have to be a little creative with our computer skills there. All right, so any questions on domain and range, guys? Usually I'll have students sit here today and go, yep, this is pretty easy. They get to a quiz or a test and they forget. What I tell you to remember is alphabetical order. What comes first in the alphabet, X or Y? X. What comes first, domain or range? Domain. So match them up alphabetical. We can do the same thing with input and output. Input comes in the alphabet before output. So X, domain, and input are all going to be together in alphabetical order. Y, range, and output are all in, together in alphabetical order. So that's one way of keeping those straight. All right, now what we want to do, ladies and gentlemen, is take these relations and that mapping and write them as ordered pairs. So I'm going to have to go to a split screen and show you guys what we're going to do with that. The reason these are called mappings is because it maps an input to an output. So we can see what this X is going to be matched up to as a Y. So I'm going to write it as an ordered pair of -3, -3. -3 only has one output, so it only has one arrow coming out of it, so that's the only ordered pair I can write from that one. If I then take a look at the next one, I've got 1, but it has 2 arrows, so that means it's being mapped. It means it has 2 outputs, so we should have -2, and then I have to list it as, again, with 1, 1. All right, so however many arrows that output has from it is how many ordered pairs you're going to make with it. And then last but not least, 4 has 1 arrow, so it has 1 output of 4, 4. Any questions on how we're taking that mapping and reading those arrows? Does that make sense, guys? Okay. So if we look at B, what would be our first, one of the first ordered pairs we could write there, Alex? -3, -3. I agree. Brooke, what would be another ordered pair I could write?
1, 1.
1, 1. Beautiful. Alyssa, what would be another ordered pair I could write?
2.
And there's one last one, Taya?
4.
Beautiful. So we have 4 ordered pairs. Kind of look through how many arrows do I have? 1, 2, 3, 4. 1, 2, 3, 4. So it looks like I've got all my ordered pairs there. One thing they're going to start doing, guys, is asking you is, does this relation show a function? And so they're going to give you examples of mappings. They're going to give you sets examples from ordered pairs. I will tell you right now, one of these is a function, one of these is not a function. Who thinks they can pick out the function from the mapping? Got to with a hand up, and Maggie thinks she's looking at it. I can tell Sebastian's thinking intently about it. I don't think he does. What's the definition of function, Jared? Go back up and look at how we define function. Is that the third word down or the second one? That's the fourth one. Yeah, what did we write for the definition of function?
Has exactly one output for each input.
Has one output for each input. How many arrows then should be coming out of an input if it's going to have exactly one output? One. So that's how we're going to look at it from our mapping. So using that, which of these two shows a function, A or B? I heard both of them. I heard A and B. Which one shows a function? B. Because which one keeps this from being a function here? Who kind of violates the rule here in that table A? One. One has two arrows coming out of it. Even though this one has two arrows coming into it, that's fine, guys. Do each of my inputs have a separate arrow? Yeah. I can cover up the inputs. I don't care what they're going to. I just need to know they each only have one output. All right. Now we want to be able to look at it as an ordered pair. So what in the ordered pairs for A would give it away that it's not a function? What of those ordered pairs would give it away? So you got to look at those ordered pairs and see that. Maggie?
-1, -1, and -2 and 1.
Ladies and gentlemen, do we have an x value showing up twice? Yeah. We don't have any x values showing up twice here, do we? But when I write them as ordered pairs, are we going to have an x value showing up twice? Yeah, so that's how we can look at our ordered pairs. If an x value repeats, then it's not a function. Okay? That means that x value had two different outputs. All right, so are we okay with the first two guys? The mappings, the ordered pairs, recognizing functions from each other? All right, I see a couple of you making good little notes in there. Good job. Now what we want to be able to do is to graph them and be able to look at a graph of a function. Okay? So graphing ordered pair, guys, this should be pretty easy. So we're going to do -3, -3. So we're going to put a point there. And then just get those four on the graph. So we're going to graph 1, 1, 1, -2, and then 1, 2, 3, 4, 1, 2, 3, 4. So you guys get yours graphed, match them up to mine. -3, -3.
You can see it on my notes. Oh, good.
You should be able to graph all of these. And 1. All right, is everyone done graphing the ordered pairs? This will probably be one of the questions on your exam on Thursday is like, name which graph matches these ordered pairs. Because did we do that already in chapter 4, guys, before this lesson? Yeah. All right, so now we want to be able to look at a graph and determine which of these is not a function. We already know A is not a function, right, guys? We've already identified that from the mapping. We know how to notice the ordered pairs because the x repeats. How am I going to look at a graph and know which one is a function or is not a function? Maggie?
On the X, on the Y, but two of them line up.
Okay. If we look up, guys, do we have two ordered pairs that are vertical from each other? And if you look, you have what's on the next thing, you have the vertical line test. And that's how we're going to use that for graphs. And it says a relation is a function if no vertical line passes through two or more points on the graph. So if we look at one that actually is a function, if we look at B, if I draw a vertical line through this far left green point, I only hit one green point, correct? If I draw it through the next one, I only hit one green point, one green point, one green point. So it passes what we call the vertical line test because we only hit one green point. But if we look at these 2 points here on the red graph, Because that's one vertical line hits 2 red points, it makes it not a function. It doesn't matter that I only hit 1 red point over here. It doesn't matter that I only hit 1 ordered pair over here. Because it hits 2 points, it's not. And so based on the vertical line test, which one is a function? Good job. All right. So you're going to be going through and say, determine which graph represents a function, explain why. Your reasons are basically yes, it passes the vertical line test. No, it fails the vertical line test. So any questions on that, guys? I'm assuming that's review. Am I correct in that? Does that look a little familiar from last year? A couple of people nodding. All right. I want to get out a split screen, and I'm going to take a look at the other stuff. All right, examples of relations and graphs that are not functions. So I'm going to pause the video here right now, and I want you guys to determine what your explanation would be on why these tables, or why this table and why these two graphs are not functions. So with your seat partners, determine what the explanation would be for not. Words would go there. So what wording, what written explanation would we give for that first one? Why is this not a function? Sasha? Beautiful. It's as simple as that. Fails the vertical line test. Could we use that anywhere else, guys? Could we use that anywhere else? On that one. Any graph, guys, that's what you're going to do. It's either going to be failing the vertical line test or passing the vertical line test. So fails the vertical line test. If you wanted to here, you could be a little bit more specific, guys. Could we say here that 2, x equals 2 has 2 outputs? Could we say that for that third graph? Because we have just the one spot that fails the vertical line test. And the reason I added that, ladies and gentlemen, is that's how we're going to explain our second one. The reason that this is not a function, I really dislike my handwriting. Because -2 has 2 outputs. When you're given a table of values, when you're given a mapping, when you're given a set of ordered pairs, you're going to tell me specifically which one has the 2 outputs, or 3 outputs, or just more than 1 output. Okay, guys? Because you can't tell me that this fails the vertical line test. Why? It's not a graph. All right? The vertical line test is specifically when you have the graph. Would this fail the vertical line test if we graphed it? Yeah, but you have to give your explanation based on what's there. Does that make sense, guys? So we're using our definition. We're using that vertical line test. All right. I like this stuff. This is really my favorite part of function notation because we get to do algebra, and I enjoy mental math. I enjoy evaluating numbers. All right. So f of 2 equals 4. What that means is that when x is equal to 4, remember this was our x value, right, guys, for our function notation? That means when x is 2, y is 4. I'm sorry. I got ahead of myself in my talking. When x is 2, y is 4. Basically, what that function notation does, guys, is it gives us a fancy looking ordered pair. All right? And so what you're going to do is actually evaluate functions. You're going to be given an input, and you're going to get the output. So what does that look like? This is our function. F of x is equal to 4x plus 2. Guys, this is really kind of a fancy way of writing y equals 4x plus 2. That's all it is. It's an equation that we're used to graphing. Okay? And so, just like we've been able to do before, we're going to take this x value, this -2, and plug it in for x. So we're going to have 4 times -2 plus 2. You can evaluate that step by step with order of operations. You can plug it into your calculator. you can just go through and do your mental math, whichever you need to do. But -8 plus 2 should be -6, correct? But we want to write our answers in function notation. So if this is my output, how do I show what my input was? Well, Michelle, what number did I plug in for x? -2. So this whole thing gets written as your function notation. The function at -2 equals -6.
This is fun and easy.
That's not too bad. This one you need to be careful of, ladies and gentlemen, because you're squaring a negative. And I think we've gone over this. This is something nice to review before your exam. You're going to have -5 plus 7, but before you plug in that -2, ladies and gentlemen, you have to make sure you put it in parentheses. We usually put what we're substituting in parentheses anyways, but we're going to make sure that we do it here, because when we square that negative, what is -2 squared going to be? What do we know a negative times a negative is going to be? Positive 4. But my calculator, I don't put parentheses around it, is going to give me a -4. So make sure that you're putting those parentheses around those, all right? So this is -5 plus 28. And so I should get 23 there. Like I said, you can work it out kind of step by step like that, or just type it all in your calculator. That's beautiful. Isaiah?
I'm confused on why we're taking the 2 from 7x and putting it with the -2 like that.
This is what this notation here, if you go back to the very first page of notes, when we described function notation, they told you this is your x value. This is the function at x. And so when they put that -2 in parentheses with that g, oops, what they're telling you is that this is your x value that you need to plug in for x. Okay? So when you see g of x, when you see f of x, h of x, guys, those are 3 of the common variables to use, f, g, and h. This is just telling you to plug whatever number this is in for x. All right? So this is your input, this is our output, and now we write g of -2. Did I answer the question you're asking? Okay, you were asking why -2 is getting plugged in there? Yep. And so almost all of your problems are going to be written this way. Guys, on your worksheet is you're going to see a semicolon, and then f of a number, g of a number there. All right, any questions? All right, let's take a look at one. Do you guys have these?
Yes.
All right, I want you guys to try 3 and 4 at your seats. I mean, you kind of, it sounds a little funny, but that's exactly what you're doing. You're taking these f of 2 and replacing f of x, but is there anywhere else on this side to plug in an x? So, ladies and gentlemen, number 4 is simply this. F of 2 equals 3. That's it. So it looks a little weird, doesn't it, guys? Because we're not doing any work. So I could give you any number here, and what's this always going to be? 3. All right? F of 2, though, should look a little bit different. What are these brackets called again, ladies and gentlemen? Absolute value. So what's 2 minus 3? -1. What's the absolute value of -1?
1.
But this negative has to come down. So your output, your final output is a -1. This does not distribute in. Those are like the Great Wall of China, Berlin Wall, nothing gets over it. Nothing gets through it. You have to keep everything outside those absolute values and just do what's inside there. Then you're going to bring down your function notation. So f of 2 equals -1. All right. Any questions there? All right. One last comment to make here, guys, is that graphing f of x equals 2/3 x plus 2 is the same as graphing 2/3 x, y equals 2/3 x plus 2. So this is my y-intercept, and this is my slope. So we would start here at 2, and I know I didn't give you guys a graph, but we'd start at the y-intercept, that starting point, and then we'd still go up to over 3, So you're still going to pull out the same values to be able to make a graph there. All right? Question from here.
These are your
Thank you.
Any tables related to this?
All right. Today. All right. All right. So ladies and gentlemen, I want to do the 2 last problems on there. I had those as bonus, and I wanted to add those in there today. We're going to do A, and then I'm going to kind of let you guys get going. And if you need help, I'll do the second one with you. Okay. So we have f at -2 equals 6, and f at 0 equals 4. We want to find slope. How do you find slope? That was something you guys did on Friday's quiz. I haven't checked it yet. What formula did you use for finding slope? How do we find that, Corbett?
1 equals 10x plus 2.
That's for graphing. How do we get m? What does m equal though? M is slope. M is rise over run. How do we calculate it, guys? Isaiah?
So if both are coordinates minus the x by the x and the y by the y.
We do y minus y over x minus x. Correct, guys? And does it matter whether I put 1 or 2 first, guys? Could it be y2 minus y1 over x2 minus x1? Yeah. Do I have enough information there to find slope right now? Well, do you have 2 y values?
Yeah.
I have a couple of people saying yes, a couple of people saying no. What is y? What's another word that we could use for y that we just learned today? Output. Do you get outputs from your function notation, guys? Yeah. So your outputs are 6 and 4, correct? So could I do 4 minus 6 to get my y's for my slope? Yeah. And then we also use input for x. And aren't those just our inputs that we plugged in? So if I give you function notation, I've given you an ordered pair, ladies and gentlemen. But the nice thing is we know that that ordered pair is automatically part of a function because we have the f with it. We only use those f's with our functions. So then we're going to have 0 plus 2 because we're going to subtract that -2. You guys have this example, correct? Okay, I've got a couple people not writing, so I'm assuming they're ahead of me. This is -2 over 2, and what does -2 over 2 simplify down to? M is equal to -1. All right, guys? So that's the second thing that you're going to be doing with those. Your worksheet tonight, you've got 4 examples to find domain and range of. You're then going to tell me if it's a function, explain your reasoning. On the back side, you have 6 evaluating problems and 2 finding slopes. All right?